Hey there, welcome back to another module. We're working our way through chapter 6 now. So this week we're going to be talking about dispersal and immigration. So before I get into that, I guess just really quickly, obviously we're doing a day late. This week I wanted to give you guys the wellness day, even though we're doing this online. I wanted to hopefully incorporate that. So your module for last week is going to be due tonight at midnight, and then you'll have a week until next Thursday for this one. So this week we're talking about dispersal and immigration, basically how organisms move around and expand their geographic range. It's not, it's not a new idea. I mean, people have known. I think, obviously, people have known that certain organisms are able to move around, and while going back to the days of Aristotle, they didn't really know things about evolution, and maybe they had some ideas about evolution, but not necessarily as we understand it. But I think they fundamentally, for a long time, anyone who studied nature has probably realized that the way organisms move around is going to have some impact. And in fact, it has a huge impact. So there's sort of three fundamental processes that we recognize in biogeography in terms of what's shaping an organism's distribution and those types of patterns. And one of them is immigration. And then we have extinction and evolution. We'll talk about those more. This week we're focusing just on immigration. So it's really a fundamental principle of biogeography as far as how organisms move around and how that it influences where they are, literally. And so I kind of introduced the beginning there, said dispersal and immigration. And while maybe in a technical sense those are two different things, we're going to, in the biogeography world, we're going to use these interchangeably. So dispersal might, in a very basic or technical way, dispersal might be just about the movement of an organism around, whereas immigration is more about establishing a colony. So an organism or group of organisms moves to a new area and actually establishes a population there. That's immigration. We're only really concerned with dispersal that results in immigration. So we're not really interested in dispersal if an organism goes to a new place and then dies and doesn't reproduce there. Well, that doesn't interest us as much in terms of biogeographical patterns. So in this context, we're using these two things interchangeably, even though there might be a little bit of a difference. We're only interested in dispersal if it actually does um, result in immigration. So we're going to use these two terms interchangeably. So if you hear me say immigration, I mean dispersal. And if I say dispersal, I also mean immigration. So just something to keep in mind there. So what is dispersal from a biogeographic standpoint? If we were to give it a definition, it's pretty simple. It's the movement of individuals away from their birthplace to new sites. And it's pretty common, it's considered sort of a life history trait for some organisms where it's just sort of programmed in. At a certain age, an organism moves away from where it was born. I mean, we as humans do this. We don't tend to very often live with our parents for very long. Although I should probably mention that there's a lot of cultural things. Some cultures do that. It's really common. So I don't know that maybe I shouldn't draw that direct comparison, but um, lots of organisms do this, and so they're sort of at a certain point in their life they will leave where they were born and go to a new site. And natural selection tends to favor this to some extent, and so we can say, in a general sense, natural selection favors intermediate dispersals. And there's sort of a lot of stuff going on here. Some organisms are, if we're talking about members of a single species, even within a species, some organisms are better dispersers than others. We can generally probably assume that young organisms are going to be better dispersers than older organisms because, they're sort of young and fit, don't have age-related injuries or problems and things like that. But a newborn isn't going to be able to disperse. You have to get to a certain age. You have to sort of become physically able to do that. So it's not like you're born. So maybe some species are born somewhat ready to go, but most are pretty much not. But there's also some other stuff going on here. And I think there's two sort of patterns that dictate this sort of evolutionary pattern as far as favoring intermediate dispersers. And those are, so there's these two patterns. So as an organism moves away from its natal range, so natal just means, the place, the birthplace. As an organism moves away, intraspecific competition tends to decrease. And so we're talking about intraspecific competition would be competition with members of your own species tends to decrease as you move away from the range in which you're born. And basically what that means is that, if you're born and let's say, you have at least one parent organism there and maybe your sibling organisms. So if you stayed there with all of them, you would have to, at the very least, compete against them for food and other sorts of resources. So if you move away, you're at least getting away from those. You're basically your family members, and so you don't have to compete against them as much. So you're decreasing competition, which is going to improve your chances of survival probably. The what do I want to say here? Sort of the opposite side of that coin, and I'm just now realizing I numbered these the same. Anyway, the other side of that coin is that habitat differentiation tends to increase as you move away. So yeah, you're getting a decrease in competition as you move away, but if you move too far away, then you're probably going to get into a habitat that is different, and that has a more likelihood of being a habitat that you're not evolved to be super fit in. Maybe you can't adapt. Maybe it's you get into a different temperature range than what is ideal for you, or different precipitation or whatever it is. The habitat, and this goes back to spatial autocorrelation stuff, where the closer you are, the more similar it's going to be. The opposite of that is the farther away you go, the more different it's going to be. So if you go really far away, you might get into a habitat that you're not going to do very well in. So these two things sort of have this contrasting, they're sort of contrasting forces, and sort of that's why you get this intermediate. It's not great to say super close because you're going to be in high competition, but it's also not great to go too far away because you're going to get to a different habitat that you might not operate as well in. So there's sort of a sweet spot in there, and that's why natural selection tends to favor intermediate dispersal, not no dispersal and not dispersal way far away, just somewhere in an intermediate range there. And we can say more broadly, successful long distance dispersal events are rare. So natural selection does tend to favor that intermediate stuff. So the rare long distance dispersal, or the long distance dispersal, is pretty rare. And it's really difficult to study for a lot of reasons, but it's also actually a really important driver of change to species distributions and long-term biogeographical trends. So it's rare for a lot of reasons. One, all the stuff I just said. We're talking about long distance dispersal here, so it's rare because it's not favored by natural selection. So long distance dispersal events are usually not successful. Organisms may fly out to a remote island all the time, but maybe they die as soon as they get there. And so it's going to take lots of those events before you can probably establish a population. But over time, this becomes a more important contributor to biogeographical trends. Like any one given event is going to have a low likelihood of success, because you're going to new habitats and crossing lots of space and all those reasons. But over, millions and billions of years, long distance dispersal actually becomes very important as far as understanding how certain organisms and how certain species got to where they are. So it's sort of a weird concept in that natural selection doesn't really favor this, and so for that reason it becomes rare. But it does happen, and given enough time, basically a large enough sample size, those events actually become important. And speaking of that, I'm going to finish up this first video here. Keep working your way through. There's a reading, pretty cool. I actually just came across this within the past couple weeks. I've been wanting to read it. So it's a story about this Arctic fox that moved, basically walked tons and tons of kilometers um, across its range. Basically, they didn't realize that something could travel this far this quickly, and sort of reshuffled some people's ideas about how this species moves around. So it's interesting little research paper. So keep working your way through the module, and I will see you in the next video.